Assessing normality with QQ plots. We have a type of graph that we often call a QQ plot, and this is used to assess whether a data set could have come from a population that is normally distributed. And this is important because of the statistical procedures that we are going to discuss that really rely on this fact. We had mentioned that normally distributed variables are very well known, and we can easily find probabilities associated with normally distributed variables. And that plays an important role in the validity of inferential statistical analysis. You might be thinking, well, can't I just use a histogram or a box plot or any of the many other graphs that we've seen to examine, hey, does my data look like it's normally distributed? Well, sure, that's a good first step. You should always look at your data, but it can be really subjective. You've maybe seen in our course, two different people might look at a distribution just slightly differently and qualify its shape a little different. So a QQ plot, also known as a normal probability plot, is a tool that's a lot easier to look at to assess, could this data have come from a normally distributed population? Beyond just looking qualitatively, does a distribution appear normally distributed, there's a lot of benchmarks that can be utilized in a quantitative fashion. For instance, we know from the empirical rule that if you have a normally distributed random variable, we know about 68% of observations should be within one standard deviation of the mean. And furthermore, 2 standard deviations from the mean should encompass about 95% of observations. That's great. But those are just 2 distinct intervals. What about the mean plus or minus some other value, some other interval from the mean, like 1.57 standard deviations or 2.18? We could certainly figure those out, but that would take up a lot of time, and there could be an infinite number of things to check there. So a QQ plot is a really nice way that's going to have a lot of input. It's kind of similar to this, but it's going to be all consolidated into a single image. So what's the deal with these QQ plots? Well, I will eventually show you some examples of them, but I want to show you what to expect when you see them. If you have observations that are normally distributed, then the relationship between those observed values and their corresponding z-scores or percentiles, I don't think I mentioned it, but Q represents a quantile. So it's a quantile plot. The relationship between your observed values in your data, those would be like your y values, and their percentiles or z-scores should be linear. And I say z-score or percentile because different software will graph these in different ways, and we know that when you have a z-score, you can look it up and get the corresponding percentile and vice versa. So one and the same. How do we get this relationship that your y values and their percentiles would be linear? Let's see. We have our z-score formula. We take y minus the mean over standard deviation. And what I want to do is illustrate the relationship between the y values and the z-scores. So I'm going to solve for y here in this blue equation. Solving for y, I need to multiply both sides by sigma, This gives me y minus mu on the right. We're only one step away to get y equals z times sigma plus mu. Okay, linear. The relationship between the y values and the z-scores should be linear. And notice here what a line looks like. The equation of a line is often written in slope-intercept form, mx plus b. And that's exactly what we've got going on here, but we are using different letters. This is essentially a line between y and z, just like this is a line between y and x. So that is the reason that a normally distributed variable y, that's your your random variable y, will be linearly related to its z-scores. Let's look at some examples. I'm going to open R and I've got some data geared up. Okay, so in this data I have called it video. And I've shown you the function tail. So I'm looking at the last several rows of this data frame called video. And notice there are 5 vectors, and they each have a name, and that name is befitting the type of distribution that is presented in that vector. So let's start with a data set that is normally distributed. I would like to first create a histogram of this vector in the normal dataset. Hist. Looks pretty bell-shaped to me, right? But certainly there are some deviations from perfect normality. If we create a QQ plot, what we're going to expect to see is a line for this data set. And I'm going to go to history recording so I can come back to these images a little easier. The code for the QQ plot is actually QQ norm. And I like to do 2 functions here. I'm going to do QQ norm, and that's going to make the graph. But by also doing QQ line, this is going to transpose a reference line for us. And what we're looking for is, or what we're noticing is that these dots are following roughly a line. And here we've got our values of our variable. If you remember from the previous image, our variable appears to be taking up values from about 0 to the mid-20s. And so our variable values are here on the vertical axis. And these are their theoretical quantiles, or their z-scores. And if this was a perfectly normally distributed variable, then this would follow that line exactly. But this is pretty dang close. Let's take a gander at what a right skewed distribution would look like in its QQ plot. But first, I would like to create a histogram to remind us what this will look like. So hopefully you believe me, this distribution certainly is right skewed. And now I am going to get geared up to create a QQ plot using the QQ norm function. I'm going to do it twice because I like to have that line superimposed. So this distribution certainly was not normally distributed. It was right skewed. And this is the classic appearance of a QQ plot with a right skewed dataset. If you take your right hand and put it to your screen, the curvature of those observations are going to kind of follow the natural curvature of your hand. Right hand, right skewed. Let's look at left skewed. We'll do the histogram first, so you believe me. Certainly appears to be left skewed. We've got our variable going all the way down to roughly negative 200 up to 50 or so. And now let's do QQ norm and QQ line. Left skewed distributions, take your left hand and the curvature of those dots kind of follows your left hand. Kind of cheesy, I know, but hopefully it works. We had a couple other shapes I wanted to show you. We've got heavy tails and an outlier. So I want to show you what heavy tails looks like. Let's do hist video dollar heavy tails. Heavy tails, and I'm going to actually see if I can give this more breaks. Didn't really help me out there, but it's always worth a try. The heavy tail distribution generally sort of follows a normal distribution, and it appears here that that normal distribution is constrained near 0. But there are a lot more observations far out in the tails. So there's heavy tails. If I make the QQ plot here, what we will see is a image that shows at some point it looks like it could be normally distributed. Right here, you see all those observations following roughly a straight line, but there is a stark deviation from that in the tails. So this does not qualify as normally distributed, as a considerable portion of the distribution deviates from normality. I think we had one more variable that I would like to show you, outlier. So let's look at a hist of video dollar outlier, and I'll do a QQ plot, do it twice, give me the nice line to reference. So here, this is why I called it outlier, because there is an outlier, and that one value has a lot of leverage, and this appears to be following a normal distribution, but you have to notice all this blank space. It's because it's making room for that outlier there at approximately the value of 20. So back in this data set, if you look closely, there are most of the values, only a few are displayed, but they're all near the neighborhood of 3, 2, and 3, and then there's a 20 in the mix. What I would like to show you one more time is a QQ plot of a normally distributed variable, QQ norm, one more time with QQ line. So this is not a perfect straight line, because that's real life for you. This relationship between the observations and the z-scores are approximately linear.